भाई 5 ही बच्चे आए हैं।
Kindly tell me if you have any difficulties. I'll solve them first and then proceed further. Anybody having any queries to ask me for the last 3 days, whatever classes we have taken here and whatever I've explained, if you have difficulties in respect to any one topic, kindly let me know now. I'll answer your queries just now. And then we'll proceed further in the class.
Sir? Hello? Hello, sir.
Anybody's any queries? Please unmute yourself and let me know.
Sir, air defense clearance who will give, sir?
Screen share.
Hello?
Yeah, if anybody has any queries, just ask me.
Yes, sir. Sir, who will give the air defense clearance?
Sir, how will obtain FIC and ADC number? We need to transmit it to the ground. No, just now I was telling you in the just before the break. You don't have to ask anybody. You just fill your flight plan and give it to your nearest ATC. Like you wanted to go from Delhi to Kolkata. In the example which I gave you before break, you will give your flight plan. Suppose you are in Jaipur, you will give your flight plan to Jaipur. There is no need for you to travel all the way to Delhi. But your flight was approved for Delhi to. You wanted to go from Delhi to Kolkata. Give it to Jaipur because Jaipur also is in Delhi FIR. Na? You give it to Jaipur. Jaipur will send your flight plan to Delhi and Delhi will give you the FIC number and send the flight plan back to Jaipur and Jaipur will tell you. No need to give it to the ground. Just give it to the ATC authorities in Jaipur. The ATC officer or the ATC supervisor in Jaipur Tower or the ATC is one building, ATC building. Just go to the ATC building and submit your flight plan there, or you can even fax it there. And they will do the needful. They will just pass it on to Delhi, and they will give you the FIC number. and Delhi will further send a flight plan copy to the defense headquarters. They'll give the ADC numbers, and that will, after getting the ADC number, will come back to Delhi, and Delhi will send a flight plan back to Jaipur, and Jaipur will contact you and tell you your FIC and ADC numbers are obtained. Okay, we don't have to transmit anything to anybody. We just have to write the flight plan and give it to them. They will get the approval and give the return flight plan with FIC and ADC numbers back to you. Yes, anybody else? Anything else?
Hello, sir.
Yeah.
So what is the MLU working? Is giving the ADC now?
Pardon?
Sir, I hear some news that ADC will given by the MLU, Momentum Legion Unit.
No, that is not related to FIC ADC numbers. This is not related to FIC ADC numbers, what you are asking me, or rather what comes in our what you call that syllabus. You are asking me something which is out of our what you call that coverage area. That is not in our syllabus. Whatever we discussed in the class for last 3 days or what is relevant to RT, yes, you can ask me.
So it's about our flight plan only, na?
Yeah.
Today.
You have to fill the flight plan, give it to the concerned ATC. The concerned ATC will read your flight plan and pass it to the main control station of that FIR. Suppose, I'll give you one example where you will get it more clear. Suppose you are in Pune, okay, and you want to take your flight from Pune to say Kolkata, Pune to Kolkata. You will give your flight plan to Pune, na? You want to go from Pune to Kolkata, you will give your flight plan to Pune. But Pune has no authority to pass your flight plan. Why? Because Pune is just a network of Mumbai. So Pune will take your flight plan and pass it on to Mumbai. Mumbai will give you the FIC number, not Pune, because Pune is the main control of that station of the Mumbai FIR. Although your aircraft is in Pune, you want to fly from Pune to Kolkata, no doubt. But Pune cannot give you any clearance to fly from Pune to Kolkata. Why? Because Pune is a network of Mumbai. It has to take consent for your flight from Mumbai. He will send the flight plan to Mumbai. Mumbai will give you the FIC number. But Mumbai cannot give you the defense clearance. Mumbai will send your flight plan further to again air headquarters Delhi. Delhi will give you ADC numbers and send it back to Mumbai. Mumbai will send it back to Pune, and Pune will give you the clearance. Okay, now your FIC and ADCs are obtained. Now you can depart. That's the procedure. Okay. The main control of that FIR will give you the FIC number, and air headquarters Delhi will give you the ADC number, air defense clearance number. Yeah. Anything else?
Sir, this FIC and ADC has some validity.
But yeah, I told you before the break when I went, I said it's a validity of 30 minutes. 30 minutes to departure. Suppose your departure time in the flight plan was 9 o'clock in the morning, 9 a.m. So you can be on the ground delayed up to 9:30. If your departure is delayed by more than 30 minutes, suppose you want to plan to depart at 9:40 or 9:35, maybe your flight plan, maybe your FIC and ADC numbers will not be considered. You will have to take a fresh FIC ADC numbers. Why? Because you had planned to depart at 9, but you didn't depart at 9. The clearance which was given to you by the FIC authority and the defense authority was on conditional that you will depart at 9, but you didn't depart at 9. You are departing after 9:30. 30 minutes consideration they can give you. If your flight can be delayed by 30 minutes, okay, the same FIC ADC numbers can be valid. But if more than 30 minutes, they may not consider it. They may reject your flight plan, and you will have to obtain a fresh FIC ADC number. So validity actually is 30 minutes from departure time. You can delay the flight maximum by 30 minutes, or whatever departure time you are given in the flight plan. Okay, but sometimes it happens, exceptional cases, the ATC feels, then even after you, suppose you delayed the flight by say 40 minutes or 50 minutes, 40 or 50 minutes, then also they can, it is up to the ATC. As per the law, you will not get a approval for flight plan if it is delayed by more than 30 minutes. But in exceptional cases, when suppose that no new traffic has come up till your departure delayed, suppose you delayed by 1 hour, if the ATC feels no, it will not affect the next of the other traffic. There is no defense traffic in the next 1 hour also. They can allow you to go. Okay. Okay. Yeah. Anything else?
Sir, I had some doubts in the map number 7.
Yeah. Tell me.
Sir, in map number 7, Chennai, Thiruvananthapuram, and Mangalore all have 3 control circles or different
Yes.
ranges, like 30
Yes.
nautical miles, 50 nautical. But sir, there
Yeah.
is only one range given, that is 5,000 feet from the control. And for the rest of the circles, there is TMA range given.
Yeah. And what about the radius? How much radius?
Sir, the first circle is 30 nautical miles, then 50, then
Okay.
75.
Yeah. So now what is your doubt? Like, see, first circle, there was no extension. Basic range was up to 30. Then the extension you said 50. Okay, that is extended up. It is extended up to 50 nautical miles, and the further 7. Now, it depending upon your flight level, like you are coming at a very great flight level, such a flight level that you want to start descend more early. Then of course, for you the third circle holds good. But if your descent is say not that much, you will require a mediocre descent, not a low level descent or not a very high level descent, some mediocre level descent, then you can really contact the control. And when you come to the second circle and the third circle, of course, when you are really coming into land, you can even contact the control or approach for the final for the destination, you can say descent up to the destination. These 3 circles, there was nothing which was not indicated, like first circle, second circle, and third. First, if there is only one circle, then it is basic VHF not extended. But if there is a second circle and the third circle, second or third is a very rare or exceptional cases, the third circle may be there. Whatever extension of the basic VHF is always remote control extension, but only for one logic, that is to give you a descent from a very high altitude. That must, there may be some flights coming into Trivandrum, especially maybe because see, you will, yeah.
So that's what I was asking. There is only one height given, that is 5,000 feet. And for the rest of the circles, only TMA range is given and no height is given. Like
No,
earlier in the map 5 we studied, we have different heights for the different circles, no? Like 10,000
Yeah,
feet,
yeah.
then 5,000 feet, but it has
Yeah,
only one height given.
Yeah, so now it is very obvious in this case that at 5,000 feet, see, you take it other way around. At 5,000 feet, the answer itself in your question. See, the answer is here in your question. 5,000 feet, you can contact from 70 nautical miles also. That is up to how much descent you want to make. At 70 nautical miles also, you can contact Trivandrum for descent. And you can contact him further. If you are not a very high altitude, you are losing height little bit late, then you can contact him in the second circle. Wherever you can contact him at 5,000 feet and take the clearance, right? But this clearance can be taken as far as 70 nautical miles if it suits you. Not 70 nautical mile distance does not suit you, you can take it at say 50. If that also doesn't suit you, you can take it at 30. Distance wise, not altitude. Maybe the altitude they kept common. Okay, 5,000 feet. That is not an issue. Okay, 5,000 feet, no problem. But the range is not same. Range is different. Whether you are coming from 70, also you can take consent. Somebody coming at 70, he may not want to lose so much of altitude. So somebody may want to lose so much. It depends on what altitude you are coming. Like I said, suppose somebody is coming at 40,000 feet, definitely he will contact you at 70 nautical miles. 70 nautical miles away, he will contact him to come to 5,000 feet. And definitely somebody is not at 40,000, somebody is at 30,000 feet. Why he will contact him at 70? He will contact him at 50. Somebody is not at 30, somebody is at only 20 or 15,000 feet. Why you will contact him at 70 or 50? You will contact him at 30. Depending on your altitude at that time, from where you want to come and descend, you can contact but it is available in the range of 50 nautical miles. Okay, it is available in the range of 50 nautical miles. It is available at 70 also, and it is available at 30 also. 30, 50, and 70. In short, it is Trivandrum extension, VHF extension is up to totally 70 nautical miles, but at an altitude for 5,000 feet. Okay, it will depend how much altitude. Suppose you are not able to come to 5,000 feet at 70 nautical miles, you may be able to come maybe at 50 nautical miles. If not at 50 nautical miles, then maybe you will come more lower at 30 nautical miles. Definitely by 30 nautical miles, you will come quite low enough to get this Trivandrum, what you call that, VHF extended. They have facilitated the entire range right from 0 to 70 nautical miles in order to give you a more cushioning, so that you can at your ease or at your convenience, you can ask for descent as per your situation, like what is your altitude you are descending to. Yeah. Okay, we'll do one to clear your doubt. we will do one or two examples when we do the question papers. I think when we do the practical example, your query will be more better solved. Okay.
Okay, sir.
Yeah. Anybody else? If anybody has anything to ask, please unmute yourself and ask me, or I'll proceed next. And in turn, like I asked you one question just before the break, how much type of traffic is there? And you somebody said 4, somebody said 2, but 2, how many types? What is that? Civil and defense? You were not. You didn't tell me. Again, I'm asking you. Again, maybe this time you may answer me. How many type of aircraft fly in the Indian airspace? How many type of aircraft fly in the Indian airspace? How many type of flight rules are there in the Indian airspace? Like, what are the flight rules generally? What are the flight rules generally in the Indian airspace? Or for that matter, anywhere in the world also. And I'll give you one example. I'll give you one hint. Again, the answer is 2. TWO, 2. Again, the answer is 2. How many type of, you can say type of flights can be undertaken? How many types of flights can be undertaken in the airspace all around the world? But basically, I'll again divide it into 2. How many type of flights can be undertaken? 2 types as per me. Now, which are these 2 types? Can anybody tell me?
Civil and defense.
File rule.
Civil and defense, I said already, that
rule.
is air traffic. No, that is not flight type of flights. That was type of air traffic, civil and defense. That I already told you. Apart from civil and defense, I am now asking you how many type of flights can be undertaken. Not how much type of traffic. How many type of flights can be undertaken. I give you a indirect answer. 2 types. I said.
2 types. One is instrument flight.
IFR and VFR.
Visual
Correct. Yeah, one is VFR and second is IFR. Now, since you told me 2 types, VFR and IFR, can you tell me what you mean by VFR? VFR, don't tell me the full form. I know the full form. VFR means visual flight rule. But can you elaborate more? What is VFR? What is visual flight rule? What do you mean by VFR?
Sir,
What do you mean by VFR? Yeah.
it's having some basic height. I don't remember the altitude.
Yeah.
It's like a pilot from where you outside window you can visually operate the aircraft. So there's no need of some instrumenting to the aircraft to help in flying. And after some level,
Right.
there's no good vision to the aircraft pilot. So we required instrument that help. So we fly under that rule, instrumented flight rules.
Okay. Now, whatever you said was okay, but technically I'll make it. You were not wrong. You reached. You were there. Nearly you reached there. Okay, good. But you do have some knowledge about that, a fair knowledge. Anyway, I will just brushing it up a little, and I'll just enlighten you more. Yeah, like you said, VFR, visual flight rules, has certain thing to with the altitude, and but you missed out one very first word: visual, visibility. It is connected with visibility. How much you can see clearly, not how far you are or how high you are, but also how far you can see. Okay, visibility, visual flight rules. Now, as per the ICAO guideline and as per DGCA, in India, we're talking about India. We're not interested in other countries. They may be different there, but in India, visual flight rules means what? For us, the interpretation of visual flight rules means when the visibility at any aerodrome where the departure for visual flights has to be done or arrival for visual flights has to be done, the visibility at that place at that time, given time, should be at least 1.5 kilometers, not less than 1.5. If the visibility is less than 1.5, even 1.4, you cannot do VFR flying. Visibility should be minimum. This is the minimum value for visual flying in India is 1.5 kilometers. If the visibility drops below 1.5, you cannot undertake any visual flying irrespective of the altitude. You may be only at 100 feet, they will not allow you visual flying. You may be only at 50 feet, they will not allow you visual flying. Visual flying will be allowed only when the visibility is 1.5 kilometers or more. One thing. Secondly, there is no criteria regarding altitude here or height here. Irrespective, what is here is that 1.5 kilometers visibility. And second criteria which comes here, there should be no significant cloud layer within a radius of 2,000 feet from your aircraft when you are flying. The route where you intend to. Suppose I want to fly visually from Bombay to Delhi. Okay, fine. Okay, I'll get my clearance for visual flight from Mumbai to Delhi on one condition. First condition is visibility at Mumbai when I depart should be at least 1.5 kilometers. If it is not that, no visual flying. Okay, suppose it is 1.5 kilometers, say it is 2 kilometers, so more than 1.5. Okay, I'll be cleared. But the second clause was there should be no significant, notice the word, there should be no significant cloud layer within a radius of 2000 feet from the aircraft on the path of departure. Entire flight from Bombay to Delhi, there should be no clouds coming on your way 2000 feet around you anytime. Now, if this is a very rare thing that this happens, because clouds are not fixed figures, they keep on moving with the winds. So this clause gets defeated very fast. So visual flyings usually are not accepted very readily for long distance flights, because on short distance flight, if you are flying for 1 nautical mile, we can really commit, okay, there will be no cloud surrounding me for 2000 kilometers. 1 mile is not a very big distance. But if you're flying for 300 miles or 400 miles, how can you guarantee that there will be no clouds there? So it becomes very difficult. So normally for long flights, we never fly visually. We always try to fly instrument flying. Anyway, so visual flying, 2 clauses are there. If you want to do visual flying anywhere in India, the visibility should be at least 1.5 kilometers from the place of departure. And also the cloud layer, there should be no significant. There may be clouds near you. Okay, just next to your window of your aircraft, there will be a small patch of cloud. No issue on that. No significant cloud layer means no dense cloud. Dense cloud definition is given by ATC. Like ATC will decide whether the cloud. Now, for your, I told you in RT, you must know a little bit of meteorology. Like temperature scale is given in, is given in degrees centigrade. If I say 40 degrees, okay. If I say 30 degrees, if I say 10 degrees centigrade, by this 10, 20 or 30 degrees centigrade, I know the intensity of the temperature. Same way, here the scale of temperature is in centigrade, but when we measure clouds, the scale is not in centigrade or not any in millibars. Pressure is measured in millibars. But the scale for cloud measurement is octas, OCTAS, octas. Clouds are measured in octas, 1 octa, 2 octa, 3 octa, 4 octa, 4 octa, 5 octa, 6 octa, 7 octa, 8 octa. 8 octa means sky is fully overcast. So ATC will measure the clouds, and in your meteorological report, they will mention how many octa of cloud is present today. As far as my knowledge goes, if the cloud is more than 1 octa, your visual flying is not going to be approved, because 1 octa itself is quite a lot of clouds. Okay, 8 octa is full sky till you see the sky is overcast, and half of that is 4 octas, and even half of that is 2 octa, even half of that is 1 octa. 1 octa itself is a very big amount of cloud. Okay, less than 1 octa, maybe less than half octa of cloud is there, then we are doubtful that you will be cleared for visual flying. So ATC will measure the intensity of the cloud. They have that clinometer. Clinometer is a device by which we measure clouds. The ATC measures clouds. The meteorological department in the ATC measures clouds and gives you the meteorological report. So in this report, the clouds should not be having a magnitude of more than at least 2000 feet. They must not be more than significant layer. No significant layers will be there. So when you satisfy both the clauses, suppose you are lucky, there is no significant cloud layer and 2000 feet radius of your aircraft from departure point to destination, and the visibility is always 1.5 kilometers. It is very rare it happens. When it happens, you will be allowed to go visual flying. Visual flying, normally when we are training to be pilots in the flying club aircraft, they allow visual flying. Mostly it is visual flying. In training, it is mostly visual flying. Then how it is done? We do local flying, mostly local flying or cross-country flight. Cross-country flight, visually, there is one condition, no significant layer, and at the same time, always in sight of ground. We should be always in sight of ground, like mountains, rivers. We are for flying. Like somebody told me just now, he was very correct by looking at the ground. Yes, visual references like mountains, rivers, railway bridges, okay, railway lines, and maybe the fields, or maybe cities or towns and villages. All these are our reference points when we fly visually. But you will agree to me, all these are man-made or otherwise nature-made pinpoints on the ground will be visible to you only when there are no clouds, sufficient, significant clouds. And there may be no, suppose you took off and you said, okay, I'll climb. Now the visibility is very good and there is no cloud 2000 feet. Okay, you took off. After takeoff, you see there are very dense clouds. After some time, you see there are very dense clouds. And you had planned that after 15 minutes, I will look at a mountain and I will know where I am. that big mountain and so on. So on the map, it is indicated there is a big mountain going to come in 15 minutes. So you're waiting for that mountain to come. Before that, a big cloud layer comes and you enter the cloud. By the time you come out of the cloud, you will see the mountain has passed you. There will be no reference point and you will be navigationally lost. So VFR flying can be very dangerous if you lose sight of the ground. That's why ATC is very particular about the visibility part and also about the cloud part. Okay, are you getting me? Yeah, anything else? Okay, nothing. So we now go to the second part, that is the IFR. What do you mean by IFR flight? IFR flight means instrument flight rules. IFR means instrument flight rules. Of course, this is a more comfortable way to fly rather. Mostly flying nowadays is done on IFR. IFR instrument flight rules, like somebody correctly said, we fly on instrument. By looking at, we don't look outside in the cockpit, we look at the instruments and fly, correct. In IFR, there is no clause of visibility like VFR. Visibility was less than 1.5, you can't fly. But in IFR, let the visibility be anything, even half a kilometer, no issue, because we are not looking outside, we are not bothered about the visibility, and no visibility clause is there in IFR, and no cloud clause is there in IFR. IFR does not have both these clauses. IFR has some other clauses. There are some conditions to fly IFR also. The first condition to fly IFR is the pilot who's flying, undertaking an IFR flight must be an instrument rated pilot. He must have a current instrument rating. Not only instrument rated, but his instrument rating given by the DGCA to him should be current. It should not be lapsed. It should be current in force the day when he is flying, not a lapsed instrument rating. And let me tell you one thing, instrument rating of a pilot is valid only for 6 months. You have to get it renewed every 6 months. Only 6 months it is valid. You have to give proof of instrument flying every 6 months and show that you still can look at the instruments and fly. Suppose you have done instrument flying practically, then that is considered as a proof to renew your instrument rating. If you have not done any instrument flying within 6 months, then a DGCA approved check examiner will check you in a simulator and do some flying with you, and then he will see whether you can read the instruments or not. If he is satisfied, he'll give you a certificate. Yeah, he still can read the instruments and fly. Then your instrument rating can become current. Okay, right. So instrument rating valid is so your pilot must be, the captain or the pilot, whoever is flying the aircraft, must be having a current instrument rating. Then only he will be allowed to fly a IFR. Second thing, the aircraft which you are flying, with the instrument rated pilot also should be instrument rating. The instrument rated. So there are 2 instrument ratings involved here. One for the pilot and second instrument rating for the aircraft itself. The pilot may be qualified. He can read the instruments, but if there are no instruments in the aircraft are not having those basic instruments which are required to do instrument rating, instrument flying. Instrument rating rated aircraft is considered that aircraft in which it has the prescribed instruments in it to allow you to go at that levels and fly. It must have all the navigational equipments to guide you at levels, such high levels where you don't have any ground reference. If you cannot have any ground reference, you are flying at from such great altitudes, you have no reference, you can just see nothing below you. Now, how do you fly? With the help of instruments. So at least you must have the instruments in the aircraft. No, you will agree to that. So when you have an instrument rated pilot and when you have an instrument rated aircraft, you can do the IFR flying. Otherwise, you cannot do IFR flying. This was the clause for IFR flying. Now again, we don't stop here. Again, my question comes back again. Somebody told me FI2 type of traffic, civil and defense. I said, yeah, okay, fine. Now you said VFR, I said, okay, fine. Again, I'm asking the same question in a different way. Can you tell me how many type of aircrafts really fly in the air? Again, the same question. Can you give me the correct answer? How many types? I agreed to you, VFR and IFR, and I explained VFR and IFR. What do you mean by that? Again, I'm asking the same question. How many type of aircrafts fly in the air? How many type of aircrafts? You can categorize it in how many types? Again, I'll give you an answer, a hint to your, not an answer, but a hint. Again, 2 types. Here also 2 types. Sir, first, yeah. Tell me.
Sir, 2 types. Lightweight aircrafts and heavyweight aircrafts.
Lightweight
less than
what the? Yeah.
Less than 5,700 kgs.
Less than 1,500 kgs, right?
Yes, sir. And more than that.
More than that. Only 2 types of aircraft you said. Okay. Anybody else? No, I said.
Categorized in civil aircraft and military aircraft.
Yeah, civil and Yeah, civil aircraft and defense aircraft we already categorized. That is, while we are doing FIC and ADC, we already categorized. And again, we categorize for VFR and IFR. Again, I want to categorize into two categories, except for these two categories which we already mentioned.
Cargo and passenger.
Pressurized and non-pressurized.
Pardon?
Pressurized and non-pressurized.
Pressurized and non-pressurized. Very correct. Pressurized and non-pressurized. Now it is very obvious. Pressurized aircraft and non-pressurized. It's, I think, anybody's answer. Everybody knows nowadays what you mean by pressurization and what you mean by non-pressurized aircraft. Now, non-pressurized aircraft basically have a limit to what altitude you can fly, because the limit actually is for humans, not for the aircraft. Now, aircraft limit is different from human limit. Aircraft limit has maybe two limits. As far as my technique, I'm not an AME, but as a pilot, I know aircraft also has two limits. One limit is the service ceiling, and the second limit is the absolute ceiling. Now, I will tell you in 5 minutes what is service ceiling and absolute ceiling. Let's just leave it now for now. Now we were talking about pressurized and non-pressurized. Non-pressurized aircraft means the pilot has a limit. Now, as you go up, you know, what is essential for us really to survive is oxygen. We need oxygen to survive, right, or to breathe. As we go at a little bit higher altitude, maybe you went to 1,000 feet, you are very comfortable. And in a non-pressurized aircraft, you can open the door and window, whatever. You can do flower dropping, leaflets you can throw in the air, fine. You can open the door and sit with your leg outside. That is what we used to do when we used to fly VFR flights, non-pressurized. Okay, that is pressurized aircraft. You can do a lot of things, like you open the window, open the door, whatever. Yeah, although it is not safe, nobody should do it, but it can be done. Okay. Then maybe same 1,000 feet, then I climbed to 2,000 feet. A very marginal difference I will notice when I come at 2,000 feet. That will be maybe I'll become little bit more lethargic in my body reflexes. But 2,000 feet is fine. I won't be like disturbed. Now if I climb again at 3,000 feet, then I'll start getting some sensations, like my vision will be blurred, or my breathing may be exaggerated, or sometimes I may get a very slight headache, something like that. If I climb further 4,000 feet, this thing will multiply. 5,000 feet, by the time I come to 5,000 feet, non-pressurized aircraft, you will start seeing things which you never imagined, or rather imagined sometimes. Things which were really not there, we will start visualizing. Now, why this is happening? Deprivation of oxygen. You got disoriented, completely disoriented. And if you dare to climb even further, 5,000, 6,000, 7,000, you may black out. That is, you may go unconsciousness. And in your unconsciousness, also, if the climb is further increased, you may die also for deprivation of oxygen. So this can be very dangerous in non-pressurized aircraft. So in India, what the DGCA has done, whether the visibility is 1.5 kilometers, whether there is no cloud at 2,000 feet radius, fine. But still, under any circumstance, under no circumstance, no aircraft will be allowed to do flying in a non-pressurized aircraft above 5,000 feet. You have to remain below 5,000 feet if it's a non-pressurized aircraft, because we have a lot of problems regarding to the, like I just now told you, breathing problem, and you can even black out. Okay. So basically VFR flying, or basically why I'm connecting this, this is all interconnected. Why I'm connecting VFR with non-pressurized? Why I'm connecting VFR with non-pressurized? Because in non-pressurized aircraft, you will not climb so much. If you climb so much, then you will not get the visual reference of the earth on which you are giving reference. So normally non-pressurized aircraft will not climb to very great altitude because of two reasons. One, no geographical references for visual flying, and no oxygen at higher levels. So you remain low, like even in cross-country flights in the flying clubs and all, mostly we do the cross-country flights well below 3,000 feet, maybe 2,500, 2,800, that's where we dare to go, not more than that for in non-pressurized aircraft. Okay. In pressurized aircraft, the thing is different. In pressurized aircraft, we can go to higher altitudes also, even 10,000, 15,000, 20,000, 30,000. Okay. Why? Because what happens in pressurized aircraft, we are able to maintain the cabin pressure as mean sea level pressure. A mean sea level pressure, all of you must be knowing if you have studied the ISA. ISA, you know what is ISA? Indian International Standard Atmosphere. As per the International Standard Atmosphere, it's just an assumption. It is not a real thing. It's just an assumption. As per the International Standard Atmosphere guidelines, we say the temperature at mean sea level is 15 degrees centigrade Celsius. Okay, 15 degrees centigrade. But is it so? If you go to Mumbai, it was never 15 degrees. As far as I know, it is never 15 degrees centigrade in Mumbai. But this is an assumption. We take it to be 15 degrees centigrade in ISA conditions, the temperature. In ISA conditions, the pressure, we assume it to be 1013.2 millibars. But it was never so 1013.25 millibars, or you can say 14.7 pounds per square inches. In okay, if you say in pounds per square inches, then it is 14.7. Okay, these are the different values. Okay, and the density as per ISA is supposed to be 1223 grams per cubic feet. But this is all values at mean sea level. At mean sea level. But is it really true that as per ISA 15 degrees centigrade, you go to Antarctica, is the Antarctica sea 15 degrees centigrade? No, it must be somewhere minus, maybe minus 20 or minus 15 or minus 16, whatever, but definitely not 15 degrees centigrade. But this is an assumption, and Mumbai is not that. Okay, now all these values are just assumptions in standard atmosphere ISA conditions, right? Now, as per these assumptions, we cannot stick to these assumptions. We have to go for the real values. Now, as I was telling you, in pressurized and non-pressurized aircraft, in pressurized aircraft, we have a problem of pressure. Like as we go up, as per the ISA, again, as per the ISA's International Standard Atmosphere Calibrations, that we have temperature also has a lapse rate and pressure also has a lapse rate. Now, temperature as per ISA decreases with the increase in altitude by 1.98 degrees Celsius. That is, we take it roughly to be 2 degrees centigrade. So we say if we gain an altitude of 1000 feet, the temperature is lost by 2 degrees. Okay, if we gain an altitude of 2000 feet, temperature has gone down by 4. If we gain an altitude of 6000 feet, 3000 feet, the temperature is gone down by 6. For every 1000 feet increase in altitude, the temperature goes down by 2 degrees centigrade. Actually, it is 1.98, but we take it as 2 degrees centigrade per 1000. That is the lapse rate of temperature in standard atmosphere. Lapse rate of pressure is 1 millibar for 30 feet. As we go up, the decrease of pressure is 1 millibar. For every 30 feet up, 1 millibar down. 60 feet up, another 30 feet up, another 1 millibar down. 90 feet up, 3 millibar down. 120 feet up, 4 millibar down. Like that, and vice versa. As you come down, the pressure will keep on increasing by 1 millibar for every descent of 30 feet. This is the lapse rate of temperature and lapse rate of pressure. Now, when this, you just observe this lapse rate of pressure. Lapse rate of pressure means 1 millibar 30 feet. As you go up, pressure will keep on decreasing. Pressure will keep on decreasing, and the pressure inside your aircraft will be maintained as 1013.25 25 hectopascals. That is the scale for pressure measurement. How? These are by centrifugal compressor, engine-driven centrifugal compressors. The mean sea level density will be, cabin pressure will be maintained. Okay, so you can say in your cabin or in the rather the entire aircraft, 1013.2 is maintained inside, but as you go up, the external pressure outside the aircraft is decreasing. So at one particular altitude, you will notice the difference between the pressure of 1013 inside your aircraft and outside your aircraft has a lot of difference. At time, if you have any such opening which can lead to depressurization is a very unfortunate thing to happen. If this happens, anything loose in the cabin or the other cabin, passenger cabin or a crew cabin, wherever, anybody sitting loose or any article or anything which is not fastened or loose will just go out of the aircraft, because there is in meteorology we say pressure always goes from high to low, never goes from low to high. Pressure always flows from high to low. This is the fundamental of meteorology. This is the fact of meteorology, that pressure will never travel from low pressure to high pressure. It will travel from high to low. So high in your aircraft inside and low outside in the free atmosphere. If there is any rupture in the aircraft anywhere, any crack in the aircraft anywhere, or any such opening which will allow these two pressures to meet, then it can be a very disastrous. It can be very dangerous. The aircraft can, suppose the depressurization again is of two types, slow decompression and rapid decompression. If the decompression is slow, then it may not affect the aircraft that much, but immediately the pilot in command, he should take a corrective action and try to descend as fast as possible to the lower levels. The moment you start descending to lower levels, the passengers will get some relief, because you are coming down. When you're coming down, the pressure is increasing 1 millibar per 30 feet. Just now I told you. So you will feel better. But if suppose the decompression is